Tonight you look into the sky and the moon is gone. Not hidden behind clouds. Not a new moon. It has completely disappeared. At first, almost nothing seems to happen. Earth does not fly away from the sun. People are not thrown off the planet. And a giant wave does not instantly swallow every coastal city. But while the first few minutes might feel strangely normal, the disappearance of the moon would begin changing our planet in ways that reach from the deepest oceans to the length of a day, and eventually, even to Earth's climate. So, what changes first? The most obvious answer is darkness. Away from city lights, a full moon can illuminate fields, cast shadows, and help people and animals navigate at night. Without it, every cloudless night would resemble the darkest part of a moonless night. The stars would appear brighter by comparison. The Milky Way would become easier to see. But for many animals, this would not simply be a more beautiful sky. Some animals use moonlight to hunt, others use darkness to hide. Sea turtles, insects, birds, and marine creatures can use the moon's light or its monthly cycle as a signal for movement, feeding, or reproduction. Remove that signal overnight, and nature's calendar suddenly loses one of its hands. But darkness would not be the greatest immediate change. That would begin in the oceans. The moon's gravity does not simply pull all the water toward one side of Earth. It creates differences in gravitational force across the planet, producing tidal bulges. As Earth rotates through them, many coastlines experience repeating high and low tides. So would the oceans become completely still without the moon? No, because the sun also creates tides. Although the sun is vastly more massive, it is also much farther away. Its tide-producing effect is significant but weaker than the moon's. NOAA describes solar tidal forces as roughly half the strength of lunar tidal forces. That means tides would continue, but they would generally be much weaker and follow a different pattern. And that creates a larger problem than simply changing where people can build sandcastles. Tidal zones are some of the most unusual environments on Earth. Twice a day, many of them alternate between being underwater and exposed to air. Entire communities of crabs, shellfish, algae, fish, and microorganisms are adapted to that rhythm. With much weaker tides, many coastal wetlands, mudflats, and tide pools would change dramatically. Nutrients would move differently. Water would mix differently. Some species could adapt, while others might lose the exact environment on which they depend. Fishing, shipping, and coastal ecosystems would all have to adjust to a new ocean rhythm. But even that is only the beginning, because the moon has been affecting something far larger than the oceans. It has been affecting time itself. When the moon raises tides on Earth, those moving oceans create friction. Over immense periods, that interaction takes a tiny amount of rotational energy from Earth. The result is that Earth's spin gradually slows while the moon moves progressively farther away. Today, lunar tidal friction increases the length of an Earth day by only milliseconds per century. That is far too small for a person to notice, but over billions of years, it matters enormously. If the moon disappeared tonight, tomorrow would not suddenly become shorter. Our clocks would continue normally. But one of the main forces gradually slowing Earth's rotation would be gone. The planet would continue rotating close to its current rate instead of experiencing the same long-term lunar braking. That raises a strange question. Without the moon, would Earth remain pointed in the same direction? Earth rotates with its axis tilted by about 23.4 degrees. That tilt is what gives us seasons. Each hemisphere alternately leans toward and away from the sun during the year. The moon's gravity helps limit how much that tilt changes. NASA describes it as preventing Earth from wobbling too much and therefore helping stabilize the climate. Without the moon, nothing dramatic would happen to the seasons next Tuesday or even next year. Changes to Earth's tilt would unfold over extremely long periods. But across millions of years, Earth's orientation could become less stable. Computer models disagree about exactly how extreme the variations would be, because the outcome depends on complex gravitational interactions with the other planets. Some simulations have found the possibility of far larger changes than Earth currently experiences. Imagine Earth leaning only slightly for one geological era, producing much weaker seasons, and then, in another era, leaning much farther over. Some regions could receive radically different amounts of sunlight. Ice could spread or retreat. Climate zones could migrate. Places that once had moderate seasons might face much harsher summers and winters. The moon would not merely be missing from the sky. Over enough time, the entire planet could feel different. And we would lose something else immediately: eclipses. A solar eclipse happens because the moon passes between Earth and the sun. By an extraordinary coincidence of apparent size, the moon can cover the sun's bright surface almost perfectly while allowing its outer atmosphere to remain visible. With no moon, total solar eclipses would end forever. There would be no lunar eclipses either. No crescent moon, no full moon, no moonrise over the ocean, and no human return to the lunar surface, because there would be no surface left to visit. But humanity would survive the moon's sudden disappearance. There would be ecological disruption, weaker tides, and a much darker night. Over extremely long periods, Earth's rotation and axial stability would follow a different path, yet the planet would remain in orbit around the sun, gravity would still hold us to the ground, and daylight would arrive the next morning. That may be the strangest part of this entire scenario. The moon could disappear, and at first, the world might look almost normal. But the longer you waited, the more you would discover that the moon was never just a light in the night sky. It has been quietly pulling on our oceans, influencing our planet's rotation, and helping steady the world beneath our feet. And we might not fully appreciate everything it does until we look up and find nothing there.